Good afternoon, Professor. We're Group 9. My name is Hassan Mahmood. Today, we're going to present on the topic Enhancing Biometric Authentication with Deep Learning, focus on face recognition and verification using Kaggle PINS dataset. And our group members are Fahim Rahman, Mohammad Fazl Ilahi Shafin, Mohammad Tawhidul Islam, and myself, Hassan Mahmood, and Akshad Bakshi. So I'll start with introducing our research project titled Improving Biometric Authentication with Deep Learning using Face Recognition and Verification on the Kaggle PINS dataset. Password and PINS are becoming less secure against modern hacking methods. This is why biometric systems like face recognition are becoming more popular. These systems use unique features like face to verify identity. However, they also have face problems like fake attacks using photos or masks. Our research looked at how deep learning can make these systems safer and more reliable. So our key objective is develop and evaluate deep learning models for facial verification, access performance matrices, accuracy, precision recall, and provide insight for improving. The problem statement is can a deep learning model achieve robust performance under constrained resources like Google Colab? So evolution of authentication. So there are traditional methods that has been used previously, which are passwords and pins, which are prone to security breaches. So biometric system uses fingerprints, facial features, and iris pattern for enhanced security. But there are some challenges also spoofing risk and synthetic artifacts like fake fingerprints. So in that case, there are a significant role that has been played by deep learning biometrics, which can handle large amount of complex data, and CNNs improve recognition across biometric modalities, including fingerprints. And impacts are improved accuracy and scalability in biometric system. And there is some advancement in facial recognition technologies recently, which are commercial systems that FaceNet, DeepFace, open source, and OpenCV. VGG Face, VGG Face 2, and applications on security systems, surveillance, and personal devices. So what we did here is we tested 3 deep learning models, which are VZZ19, ResNet 50, and custom CNN, to see how well they work to face verification. And we used Kaggle PINS database and limited resources like Google Colab to find practical ways to improve biometric systems. Here you can see VGG19 uses 19 layers with small filters to capture fine details in images, and it has limitations. It's computational overhead in resources constrained setup. And ResNet 50, it has 50 layers with residual learning to solve vanishing gradient issues. And it has benefit that it can extract features at multiple levels of abstraction. And there's a research gap which underexplored performances in adversarial conditions. And custom CNN is a tailored for specific biometric tasks. Insights from Simonian and Valerides improved optimization. And impact is enhanced accuracy and feature extraction for facial recognition. So from here to onward, my friend Akshad Bakshi will continue. Thank you so much.
Thank you, Hassan. I, Akshad Bakshi, will talk about how biometric authentication has improved over time and role of deep learning in it. So biometric systems like using facial features or fingerprints are safer than passwords because they are unique to each person, but they will have risks like being tricked by fake faces. Deep learning, especially with CNNs, has made a big difference in improving biometrics. These are great at understanding image data. For example, models like VGG19 and ResNet 50 has made face recognition more accurate. Tools like OpenCV and advanced model like FaceNet have also helped a lot. However, some systems don't work well with limited resources or in tricky situations. However, our research focuses on testing how will these systems perform in such cases. With that, I will hand it over to my friend Fahim, and he will explain about the methodology.
Thank you, Akshat. Now I will explain how we did our research. I will walk through our methodology framework for evaluating deep learning models in facial recognition and verification tasks. Our approach involves several key steps. Firstly, data acquisition. In the data acquisition part, where we used the Kaggle's PINS face dataset, where there is a rich collection of Pinterest images cropped specifically for facial recognition. In the pre-processing and augmentation part, to standardize and enhance the dataset, neural network design leveraging the architectures like VGG 19, ResNet 50, and the custom CNN. For the development of the facial embeddings, we translate the images into high dimensional vectors for verification. And for training, fine-tuning, and validation, we optimize our model performance. And for performance evaluation, we uses metrics like accuracy, precision, recall, and AUC. So our dataset contains 17,534 images of 105 celebrities. Um, mm, it offers a relatively balanced distribution with minor variability, which is ideal for robust analysis. To ensure a focused approach, we used 100 celebrities for initial training and validation, then narrowed down to the top 50 celebrities for detailed optimization and performance analysis. This comprehensive framework has allowed us to rigorously assess our models and extract valuable insights into improving the facial recognition technologies. So we used Kaggle's PINS face image dataset, which has over 17,000 images, as I have said, in 105 categories. So we prepared the data by detecting the faces, aligning them, then resizing and using the techniques like flipping or rotating the images to make the models more robust. Next slide. So we tested three models. First, VGG19, a deep neural network renowned for its precision in recognition, recognizing images. With 19 layers, it dives deep into the data, capturing intricate details. This model is like a seasoned artist, picking up a subtle nuisance that makes it excellent for distributing even the smallest difference in the images. Uh, for ResNet 50, it's also a good model. This model tackles one of the toughest challenges in the deep learning, training deep learning networks without losing accuracy. By incorporating shortcuts or skip connections, it ensures the information flows seamlessly. So avoiding common pitfalls like vanishing gradients. Think of it as a highway for data, speeding up learning while maintaining the clarity. Second. So lastly, this is our custom CNN, uh, where we specialize specifically design with 5 layers tailored to our data set. So it's a solution optimized to perform exceptionally well in recognizing and verifying faces. So unlike pre-existing architectures, we in our model so reflects the unique um, requirements and challenges, providing that sometimes handcrafted tool can outperform the existing models. Um, So in summary, we can say that VGG19 celebrated for its precision in capturing fine images details. There's uh, mm, network for training challenges using shortcuts to ensure smooth data flow. And finally, our custom CNN is a tailored model with 5 layers, is optimized specifically for our dataset. Uh, so we trained these models and measured the performance using metrics like accuracy, precision, recall, and AUC. This helped us see how well they could work in the real situation. Now I'll hand over my speech to Shafin to share the results and outcomes of our work. Thank you very much. Thank you very much.
Hello everyone, my name is Shafin and thank you Fahim. And let's go over the results and comparison. And each model performed differently when working with limited computational resource. Okay, let's talk about BGG19. This model learned quickly at the start, but had trouble improving during later training, and it reached 70.3% accuracy. Next slide, please. And the ResNet 50, you can see this model this model struggled with overfitting at first, leading it to lower accuracy at 41%, but it showed improvement after fine tuning. And lastly, the custom CNN, that model performed the best. It had a accuracy of 75.2% accuracy and a good balance between precision and recall. Next slide, please. Next. Okay, as you can see, the precision of VGG19 is 0.74 and recall is 0.68, and that's pretty good. And but the ResNet 50 got a low accuracy and AUC also. Like as I said earlier, it struggled with overfitting at first, but the CNN got a good mark with 75.2% accuracy and 92% AUC. And next slide, please. When we compared the model, we found that VGG19 and ResNet 50 benefited from pre-trained knowledge, but needed more fine-tuning to adapt. On the other hand, custom CNN built specifically for our dataset did really well because it was tailored to the task. And these results show the trade-offs between using complex model and managing computational resource effectively. Okay, now I will hand over to Rahul to wrap up with the discussion and future directions.
Hi. Thank you. My name is Mohammad Tauhidul Islam. I'm discussing about our limitation, conclusion, and future work. For our results show that custom deep learning models can work really well for biometric authentication, especially when resources are limited. However, there are some issues. The dataset we use wasn't very diverse, and the limited computing power of Google Colab made it hard to do more extensive training. Fixing the problems in future research could give even better results. Our work gave useful ideas for creating safer and more efficient facial recognition system. In the future, researchers could try more advanced models like transformers or hybrid systems and use larger, more diverse datasets to improve performance further. Thank you for listening, and we are happy to answer your question if you have. Thank you.